And good morning to everyone. So our today's lead code question is 1404. That is the number of steps to reduce a number in binary representation to 1. So in this question we are given the binary representation of an integer as a string, and we have to return the total number of steps to reduce that number to 1. And what are the rules we have to follow? So if our current number is even, then we have to divide it by 2, and if the current number is odd, then we have to add 1 to that number. And even they have guaranteed that we can always reach to 1 for all test cases. So let's see some example to understand it more clearly. So we are given a string s is equal to 1101, right? So here the first bit is 1. That means our number is odd, right? So what we do is we will just add 1 to it. So when we add 1 to it, it will become 1110. Now again if you'll check uh, the first, and now our step is up to step is 1. Now if we check, this is 0. So it is even. So we'll be divide by 2. So divide by 2 means we'll be left shifting it. So we'll be left with 1 and matlab 3 ones. Then again we will be doing the same thing, and at the end until we reach to 1, we have to count the total number of steps. So see, here initially it is 13, so we add 1, so it becomes 14. 14 is even, so when we divide by 2 it becomes 7. Again 7 is odd, so we'll be adding 1, so it will become 8. Again 8 is even, so divided by 2 is 4. 4 is even, right? So divide by 2. Again 2 is even. Then again we divide by 2 and we get 1. So we have reached our uh, final destination. So how many steps we have taken? So we have taken 6 steps. So that is the answer. So if we see the next example, so in next example we have 1 0, that is we have 2. So 2 is even, so dividing by 2 we get our answer 1. So only one step, and here it is directly given 1, so there is no need to do anything, so number of steps is 0. So if you see the constraints, the string length can be up to 500 characters, and it consists of characters 0 and 1, with the constraints that the first character is always 1. So let's see the approach one, that is the direct simulation on the string. So what is the idea? So in if the last bit is 0, then that means that number is even, so we have to divide by 2. That means we directly remove the last character. So suppose we have 1110. So see, the last bit is 0, that means the whole number is even number. So what we do is we have to divide it by 2. So this is 14, right? So 14 divided by 2 is 7. So how will we represent 7? 4 to 1, right? So if you notice, if we remove this character, is aren't we get the same answer? Yeah. So we'll be popping last character. Now if last bit is 1, so see, last bit is 1 and length is greater than 1, length is greater than 1, then that means the number is odd, and we have to add 1. So we have to add 1 to this number. And in binary we know 1 and 0 gives us 1, 0 and 1 will give us sorry 1, 1 and 1 will give us 0 with carry 1, right? So see this example, we have 1 1 1, and so as it is odd now, so we have to add 1. So see, 1 and 1 it will become 0 with carry 1, then again 1 and 1 it again becomes 0 with carry again 1, 1 and 1 again 0 with carry 1. Now the string is like exhausted, like the string is completed, so we just add the carry 1. But see, when we have to insert this new element in the string, we have to shift all the previous characters by to one position ahead. So shifting will take big of n time, right? So in worst case the time complexity of this approach will be big of n square, though it will work with the given constraints, but the time complexity is big of n square. So let's see the code part. So in the code what we are doing, we are using a while loop until our string length do not becomes 1, and then we are checking whether the last character of the string is 1. If it is 1, that means add odd number, so we have to add 1. So for adding 1 what we are doing is we are initially taking the carry as 1, means adding 1 is like carry. So see, uh, then we are going to each character, and we are checking like what is the bit value. So bit value can be either 0, 1 or 2, right? Suppose carry is 1, carry is 1, so either 0 plus 1 or 1 plus 1 will give us 2. So carry 0 means 0 plus 0. So we'll be getting these three possible bits, right? And then what we are doing is we are doing AND operation with one of these bits. So suppose we have 2 and with 1, what it will give us? It will give us 0, right? And it will give us a carry 1. So we are storing uh, the new character in s of I, and we are storing our carry. And suppose if our carry has become 0, then there is no need to go ahead and process all the elements, right? There is no need to go ahead. Suppose see this example 1001. So if we'll be adding 1, then 1 and 1 will become 0, and now our carry is 1. Now 1 and 1 0 is 1. Now our carry has become 0. So if carry has become 0, we just have to return all the same elements will be there. So no need to process those. And after this loop, if carry is equal to 1, that means we have to add a new element to the string. So we insert a new element to the string at the beginning, right? So we are passing the pointer and what is the character that we have to add. The second case is suppose if the number last bit is 0, last character is 0, so we just remove the last character, and we increment our count, or we say steps by 1, and at the end will be result returning result. So in worst case the time complexity of this approach can be big of n square. So let's see the second approach. The second approach is like I have thought of like converting the string to integer and then perform bit manipulations on the integer, because that will be easier. But the thing is that the string length over here is up to 500, so we cannot convert it either to integer or long. So like this is not possible. This approach we can't do, right? But assume if it is possible to convert to integer, then what we have to do is then we just have to do this thing, like we will be using a while loop in which we are checking if until n is not equal to 1, and then we'll do AND operation with 1. So this is to check whether the last bit is 1 or 0. So if last bit is 0, then AND with 1 will give us 0, right? And in suppose if the last bit is even, then we have to divide by 2. Divide by 2 means right shift, right? So we are right shifting by one bit. And if it is odd number, then we just adding by 1. So this will be easier, right? But the thing is that we can't convert the string of length 500 to integer. So this way this approach is not possible. Let's see the approach 3, which is the like optimal approach. So in this what we do in the approach 1, when we are uh, getting an odd number, and then we have to add 1, right? And instead of like at that time we were adding that one to the whole string, so instead of adding that to the whole string, this time what we do is we will simulate it a bit differently. See, in approach 1, suppose we have this string, and now the last bit is 1, so it is also we have to add 1. So 1 and 1 0. So last time we were adding it to the overall string, right? But this time we'll be taking a different process. So let's see that idea. So what we do is we'll be processing from right to left, and we won't be processing the first bit. Why we'll be skipping the first bit? Because when string length becomes 1, we have to stop, right? That's our condition. So at each bit, what we do is we move from right to left, right? We move from right to left. Then we check the bit. So bit is s of I, that is string minus. Why we are doing it subtracting? To convert it to integer, and then we are adding our carry. So s of I can be either 0 or 1, and carry can be either 0 or 1. So 0 is 0. So what are the possible values we can get? So we can get either 0, it will give us 2, it will give us 1, it will also give us 1. So the possible values of bit can be 0, 1 and 2. Now let's see the different cases for all these possible values. Suppose case 1, if our the bit value that we get is equal to 0, that means the number is even. So in even, what we have to do is we have to directly divide by 2. So directly divide by 2, so we will be increasing steps by 1, and our carry will remain same only, right? If you'll see here, 1 and 1 in binary, it will give us 0, and carry will be 1. So you, if you see, the carry is intact, it hasn't changed. So case 2 is like, suppose our bit is equal to 1, our bit is 1, that means the number is odd, right? So in odd number, what we have to do is we have to add plus 1, right? So adding plus 1 will make it even number, right? And once we get the even number, then we'll be divide by 2 at the on the spot, right? We won't be adding that one to the whole string, right? We are just taking, we are just looking at that index I, at that index, and then checking, right? So what, how much steps that we have to increment? One is like, first adding one, step 1, and then dividing by 2, so total 2 steps, right? And our carry will become 1, right? Let's see an example. Suppose we have 1 0 1. So now our bit is 1. So what we'll do is we first add 1. So 1 and 1, it will become 0, and we get a carry 1, right? So now we won't be adding this part at this point. At this point, what is our focus? Our focus is to remove this even, because we know our last bit is 0 now, so it is an even number. So we divide by 2 here. So again one more step. So total steps are 2. See, now in next step, this part is done. In next step, we know what is our carry. Then we again do the same operations for this. So 1 plus 0 is 1, right? 1 plus 0 is 1. So again it is odd, right? Our bit is 1. So again it is odd. Again we'll do the same thing, right? So we are not iterating through the whole array. So that's why it will reduce our time complexity to big O of n, from big O of n square. Let's see the case 3. Case 3 is equal to, suppose our bit value is equal to 2. So suppose our s of I, string value is equal to 1, and carry is equal to 1. Then 1 plus 1, we will get 2, right? So our bit value is 2, means the number is even. So if it is even, what we have to do? We have to divide it by 2, and carry will be same only, because in binary 1 and 1 is 0, and it will give us carry 1. So carry is same only. So we will be increasing the step by 1, because just have to remove this 2. And once we finish the loop, that means we are reaching the most significant bit, right? In the above loop, we are iterating from the last character up to the index 1. We are not checking the index 0, because we want one length, right? So at that point, if carry is equal to 1, what we need? We need one more extra step. Suppose if s of I is 1 and carry is also 1, then 1 and 1 is 0, and 1 carry. So we are left with this element. So to remove this, we know we need one more step now. that step will be adding. So at the end we'll be returning steps plus carry, like total steps that we get up to here, and then we'll be add carry. So if carry is 0, then directly we get this answer, else we add this carry. So let's see the code part. So in code, we are finding the size, carry is equal to 0 and initially steps is 0, and then we are processing from right to index 1, right? I is equal to n minus 1, I is greater than equal to 1, and we are decrementing the index. Then we are finding our bits, converting the uh, value of the string to the integer and then adding carry to it. Now if bits is equal to 0 or bits is equal to 2, as we have discussed above, then we have to increase the steps by 1. Else if bit is equal to 1, that means our number is odd, so we have to first add 1 to it, make it even, and then divide by 2. So two operations, and carry will be 1. And at the end when we return here to most significant bit, and suppose carry is 1 and most significant bit is also 1, so to make it of, it will become 1 0, that is length is 2, so make it 2 length as 1, or we need one more operations, so we'll be adding carry to simulate that. If carry is 0, then 1 plus 0 is 1, so we directly return our previous steps. So this is our code. I hope I am able to explain you the whole process properly. So if you like the get the solution, please make sure to like, share and subscribe the channel. Thank you.